warahmatullahi wabarakatuh, and salam sejahtera. So this time we're going to discuss the remaining question of the tutorial 5. Okay, so for the question number 9, a rod of length 1.5 meter move perpendicularly to a uniform magnetic field of 0.7 Tesla at a speed of 25. So maybe I can write down the information first. Length is equals to 1.5 meter. Magnetic field equals to 0.7 Tesla at the speed v equals to 25 meter per second. Okay, and the resistor of the rod is 7 ohm. So this one is actually a rod wire, so it's basically a rod lah. So when the rod move across a magnetic field, what happens is that you have a change in area. So that one we discussed it in our previous part yang subtopic tu. But now we just want to solve this one. So to solve this one is very straightforward. You have one particular formula where EMF equals to BLV sine theta. Okay, the theta here is actually equals to 90 degrees because the B is going upwards, and your V to the right or to the left, it doesn't state to the right or to the left, it doesn't matter. So if you look at this one, so you can see that V is pointing one direction like that, and the B is either down or up, kan? So tak kisahlah V kamu ke mana pun, and they always 90 degrees. So in this case it will be sine 90, which is equals to 1. So this one I can write as 1 as straight away. So magnetic field equals to 0.7 multiply with the length 1.5 and velocity is 25. Okay, this one would be 262.5. Sorry, salah tekan. It's 1.5, which is 226.25. Okay, but this one is actually the values of induced EMF. If I want to find my induced current, I can use Ohm's law. Where my V is equals to IR. So my V is basically the EMF lah. So I'm going to change that one to EMF equals to IR. I equals to 26.25 divided by the resistor 7. So here I got 3.75 ampere. Okay, moving on to the next question. Question number 10. The coil of a generator has 50 loops and cross-sectional area of 25. So numbers of loops is 50. Cross-sectional area is 0.25 meter square. Calculate the maximum EMF generated by this generator. This is the generator, you can see here on the right. So this one just so that you can get some ideas lah. Angular velocity is 4 radian per second and magnetic field is 2 Tesla. So again, like I told you previously, this chapter masa kamu belajar nampak macam banyak sikit nak belajar, but then when you try to solve the question, normally the question is very straightforward, masuk formula je. So don't worry, okay. So I take out all the information here. 50 loops, cross-sectional area, maximum EMF, they want to find the maximum EMF, angular velocity. Okay, everything is in SI unit, so should be okay. So you can solve this one using equation NBA omega. So because they want you to find the maximum, that one's actually ada degree juga, tapi maximum equals to 1 lah. So this one will be a max. So if you want to substitute all the values, it will be 50 to 0.25 and then 4. Okay, this kind of question, if you get it wrong, most probably kamu salah tekan lah. Okay, make sure you use the correct formula. So the masalah student biasa dia tak boleh kira, dia tak boleh gunakan formula yang betul, itu je. Question number 11. 1200 turn coil of an AC generator has an area of 5 times 10 negative 2. Okay, rotating uniform magnetic field. Magnitude of maximum induced is 35. Okay, so basically this one has the same diagram. Okay, this is the situation, sama je. You expect the formula will be the same as well. Okay, angle dia sentiasa ni sistem 1. So NBA omega, again I use the same formula. Okay, this one is for question 11. 35 equals to 1200 8 times 10 negative 2. Okay, and then straight away you can find the omega. Betul, You have to be careful if they give you in different unit other than SI, but this time they give you in SI unit, so final answer will be in SI unit as well. So it will be radian per second. Okay, moving on to the question 12. The question number 12, you have question A and question B. I'm going to answer the question B lah. Itu you can do it yourself. Okay, tak masalah. Okay, calculate the inductance of a solenoid containing 200 turns if the length of the solenoid is 30 cm and its cross-sectional area is 6 cm square. So if you take out the information, so this is the solenoid. The length is represent this length lah. The length of the solenoid. Numbers of turn. Area is given straight away. So if you want to calculate self-inductance, that one the formula is L. Kalau mutual inductance, the formula is M. So it will be mu naught N squared A over L. Okay, biasakan tengok dekat depan kamu punya buku tutorial tu, formula sheet. So it will be 4 pi times 10 negative 7 N equals to 200 square, jangan lupa, 6 times 10 negative 4. The length here is equals to 0.3. So actually they give you in centimeter, and you just change to SI units. Okay, here I got 1 times 10 negative 4. So 1.01 times 10 negative 4, unit for mutual inductance will be Henry. Sorry, this one is self-inductance. So L dengan M inductance, unit is the same, Henry. Okay, question number 13, B. Okay, this time they ask you to find the energy stock. Okay, energy stock, if you want to find, you have one formula where U equals to half Li square. Okay, but if you want to use this formula, you need to have value of L and I. So L is given 30 times 10 to the power of negative 3. So the question actually asks you to find resistance is given as well, V is given, calculate the energy stored. Okay, so you can use Ohm's law. Where V is equals to IR. Okay, I can find my I straight away, which is V15 divided by 0.5. That one is 30 ampere. Okay, once I got this one, I can solve using U equals to U equals to half L is given. Okay, jangan lupa square. So you got here is 13.5. Okay, use the SI unit. Final answer will be in SI unit, which is Joule. Okay, and then question number 14. Okay, find the coefficient of mutual inductance of two coaxial solenoid of 5 cm radius and 30 cm long if one solenoid has 10 turns and the second has 1000 turns. Okay, so what does it mean by coaxial? It's actually something similar to this. You have one in the middle and the other one, the axis is the same. they share the same axis lah. So in this case actually the radius is the same, but in this diagram yang saya tunjuk ni dia punya radius tak sama, ada dua radius. So I just show you this solenoid to show you the idea of coaxial. See? Okay, but ignore the fact that this one has a different radius. So this one you will expect radius is the same except numbers of turns is different. One has 10 turns, another one has 1000 turns. So they just want to find mutual inductance. You can use the formula M equals to mu naught. Kalau self-inductance dia N square, this one dia ada N1, N2. Itu je beza dia. Yeah? So very straightforward and simple. Okay, the radius is 0.5, so you have to change to area, which is pi times 10 to the power of radius square. The length here is 0.3 meters, so that one's about 30 cm. Okay, jangan salah tekan your calculator. Make sure you know how to press 4 pi times 10 negative 3. Press it yourself, jangan harapkan saya je. So here I got 0.03. Betul tak? Saya double check maybe saya kena double check.
Nanti
Okay, if I double check this one, it will be
sebab saya cuba guna whiteboard, tak, budak pun tak boleh link tak, macam mana? Okay.
Okay, I got here it's 3.29. So tadi maybe saya salah tekan. Times 10 negative 4 Henry. Okay, kalau saya salah tekan, saya salah tulis, kamu check balik lah. Okay, the last question actually, question number 15. So this one is something that is very similar to the passive question lah. I expect if they ask you about mutual inductance, it will be something like this. Okay, a primary solenoid 50 cm in length has a radius of 6 cm and 500 turns. So I take out this information here. Calculate the self-inductance in primary and secondary. So you have two, primary and secondary. So it could exist in coaxial macam yang tadi kan, dalam satu axis, ataupun dia boleh letak side by side, it doesn't matter pun. Biasanya lukisan ada this tu lah. So the primary is this one. Okay, has a radius of 6 and 500 turns. Current is flowing through at the rate of 2.38 second. So the current actually flows in the first one. Okay, so biasanya macam tu lah. Yang ni primary, secondary tu yang ada induction. Okay, cuba kita buat the self-inductance in primary solenoid. Okay, so self-inductance is L. Senang L equals to mu naught N square E over L. So 4 pi times 10 negative 7. N for primary is actually equals to 500. And for secondary would be equals to, so maybe I can write N1 and N2, which is equals to 80 turns. Square. Area is not given, but they give you the radius, so you have to use pi r square. Okay, the length here is 0.5. I got here 7.11 times 10 negative 3. The unit would be Henry. Okay, and then for mutual inductance, dia tak tanya for mutual inductance, they ask you to find the induced EMF in the secondary solenoid. So if you want to find that one, you expect to have to use mutual inductance punya value. Okay, so this one is for question A. For question B, basically if I want to solve, induced EMF equals to negative m di dt. So di dt is given here. Okay, you can use that value straight away, but you need to find the values for m first. Okay, let's find the m first. M equals to u naught n1 n2 a over l. Okay, since the a and the l is the same, just substitute all the values. Okay, so if you calculate A separately, you can use that value straight away. Tapi sebab tadi saya tak calculate separate, I still have to press lah. So this one, I got 1.137. Okay, what did I do just now is that I divided by 500 and multiplied with 80 from previous answer. Okay, and then the last one, if you want to find EMF equals to negative m di dt negative 1.137 times 10 negative 3 multiply with di dt, which is given as 2.3 ampere per second. How do you know that? You can check the unit, and that one is per second, so it will be I per t lah. I got here negative 2.6. Okay, this one is volt, sorry. So you can either write in millivolt or you can leave it like that. Okay, I think that's all for this tutorial. Okay, thank you.